Hello class, this is Mr. Lehman. Today we're going to take a look at some gas stoichiometry, and we're going to focus today on stoichiometry at standard temperature and standard pressure conditions. The next tutorial we'll look at non-STP conditions. Alright, so let's go ahead and get started. So it's a quick review. Standard temperature and standard pressure, a set of standard conditions that scientists use to compare gases. Temperature is equal to 273 Kelvin, which is 0 Celsius, which is the freezing point of water. And pressure is equal to the pressure on a typical day at sea level, which is 1 atm, which we know is equal to 14.7 psi, 760 torr, 760 millimeters of mercury, and 101.3 kPas. At STP, we established that gases take up 22.4 liters of space, of volume, per mole. So for every 1 mole of gas you have at STP, it'll take up 22.4 liters of space. And that's just an application of Avogadro's law, saying that equal volumes of gases at the same temperature and same pressure take up the same amount of space, same volumes. And so 1 mole of any gas takes up 22.4 liters. So we can use that to do some gas stoichiometry as another conversion. And 22.4 liters, once again, 6.02 times 10 to the 23rd gas particles at STP will take up this much space. And that's about the size of a big beach ball, maybe a little bit bigger than a big beach ball. Alright, so this is our Stoichiometryville graphical organizer. Up to this point, we've been starting with mass, dividing by the molar mass to get moles, or starting with the number of particles, dividing by Avogadro's number to convert into moles. But now, we're going to take a look at this. So if you're at STP and you start out with the volume of a gas, we can divide the volume of a gas by 22.4 liters per mole to convert into moles. Alright, and then the second step is the same step that we've been doing. We're going to take the moles of known, multiply it by the ratio of unknown over known to figure out how many moles of unknown we have. And then step 3, if it asks for how many grams of unknown we can produce, we'll multiply by the molar mass like we did last unit. If it asks for how many particles of the unknown can we produce, then we'll multiply it by Avogadro's number like we did last unit. But the new thing is this: if it asks for, well, what volume of a gas can we produce of our unknown? If we're at STP, we can multiply it by 22.4 liters per mole. So 2 new options here. If you start out with volume, you can divide by the molar volume of a gas. At STP, if it asks you to solve for volume of a gas, at STP we can multiply by the molar volume of a gas, 22.4 liters. So let's work through 2 examples to show how this is applied. So water, when we pass an electric current, can be decomposed into the hydrogen gas and the oxygen gas that it's composed of. We need to balance this equation as always for stoichiometry. So 2 of these, and 2 of these, and 1 of these. So 2 waters can decompose into 2 molecules of hydrogen and 1 molecule of oxygen, or 2 moles of water can decompose into 2 moles of hydrogen gas and 1 mole of oxygen gas. So we're starting out with mass. Alright, so if we're starting out with mass, we need to divide by the molar mass to find the moles of what we know. So let's go from here to here first. So we're going to take 20 grams of H2O, and then we're going to divide it by the molar mass. So 1 mole of water is equal to 18.02 grams of water. Canceling units. Then we need to multiply by the ratio. Unknown goes on top, so we're trying to solve for hydrogen. 2 moles of hydrogen gas can be produced from 2 moles of water decomposing. And then because we're at STP conditions, I didn't write that up here, but we're at standard temperature, we're at standard pressure, we can use our new conversion factor, which is the number of moles times 22.4 liters per mole. We only can use this at STP once again. So 22.4 liters of hydrogen is the volume of every mole of hydrogen gas. So if we go ahead and multiply this all together, we get about 20 divided by 18.02 times 2 divided by 2 times 22.4 we get 24.9 liters of hydrogen gas. Alright, that's the first part of it. Second part of it, what about the oxygen? Alright, so everything else, all the rest of the problem is the same. We still start out with 20 grams of water. We're still going to divide by the molar mass of water to turn that into moles of water, which is about 1.1 moles. But the ratio is different, right? We only can make 1 mole of oxygen for every 2 moles of water. So there's a 1 to 2 ratio, and then because we're still at STP, each mole of oxygen will take up 22.4 liters of space. And when you multiply or divide 20 by 1802, multiply it by 1, divide it by 2, multiply it by 22.4, we get for an answer about 12.4 liters of oxygen gas can be produced. And that makes sense because 2 to 1 ratio, we only can make half as much oxygen as we can water, or as hydrogen from the water. Alright, so I hope this helps. Let's do one more. Alright, let's do one more. I want to show you volume to volume at STP. We can take a shortcut here too. So here we have benzene combusting, and the question is if we use up 15 moles of oxygen in the combustion, or excuse me, that's the ratio. If we use up 25 liters of oxygen in the combustion of benzene, how many liters of CO2 can we produce theoretically? So the ratio is 15 moles of oxygen will produce 12 moles of CO2. So we're going to take what we know. We're starting with 25 liters of oxygen. And because, once again, we're working at STP in this tutorial, then we know that 1 mole of any gas, including oxygen, will take up 22.4 liters of volume. So that's our first step. Take the liters that you had divided by 22.4 to convert into moles. We then multiply by the ratio. 12 moles of CO2 can be produced from 15 moles of O2. And then it says, what volume at STP can you produce? Alright. So we know that each mole of CO2 that we produce, because we're still at STP, will take up a volume of 22.4 liters. Alright, so moles cancel. Now if you look at this, because we're at STP, over here we're dividing by 22.4, over here we're multiplying by 22.4. So effectively these two things cancel out. 22.4 divided by 22.4 is just 1. So when you're going volume to volume, the nice easy shortcut is you can just multiply it by the ratio, unknown over known, to get an answer. So we're going to take 25 liters, we're going to times that by 12, divide that by 15, and we would get, as an answer, 20 liters of CO2 gas can be produced. Alright, so I hope this helps. If you have more questions, come in for help. Next tutorial we'll look at, well, what happens if we're not at STP. Thanks and have a good day.